Hello there, and welcome back. What we're going to do in this video is use a system of equations to find all the intersection points between the hyperbola x squared minus y squared equals 4 and the ellipse whose equation is 3x squared plus 2y squared equals 22. So the first thing we're going to do is set this up as a system so we can see what our best plan of attack here is. So I'm going to write x squared minus y squared equals 4 followed by 3x squared plus 2y squared equals 22. And it looks like an equation that we could solve by elimination because we only have two different terms. We have an x squared and a y squared. So that's going to be the plan of attack for this problem. I'm going to multiply the first equation by 2 on both sides, and that's going to enable us to eliminate the y squared term when we add. So you have 2x squared minus 2y squared equals 8. And we have 3x squared plus 2y squared equals 22. So if we add those two equations together, we have 5x squared equals 30, which means x squared equals 6. And that means that there is actually two potential x coordinates, plus and minus the square root of 6. So just as we're used to doing, we're going to plug each one in and see what the corresponding y coordinates are. So I'm going to choose x equals the square root of 6 first. I'm going to use the equation x squared minus y squared equals 4. So you have square root of 6 squared minus y squared equals 4. Square root of 6 squared is 6. And if we solve that for y squared, we get y squared equals 2. Which means y equals plus or minus the square root of 2. Now that means that there's 2 points where x equals square root of 6 is a solution. So to organize this information, we're going to write them as ordered pairs. So you have square root of 6, square root of 2, and, whoops, I'm sorry, not negative square root of 6, still positive square root of 6, square root of 6, negative square root of 2. So there's 2 solution points right there. Now you can probably tell the same thing is going to happen when we plug in negative root 6. Let's just double check that. So x equals negative root 6. We still have x squared minus y squared equals 4. So negative root 6 squared minus y squared equals 4. Well, negative root 6 squared is still 6. So we just solved that same equation up above there. So we know that that results in y squared equals 2, which means y equals plus or minus square root 2. So that there means that when x is negative square root of 6, there are 2 values of y that correspond. Negative 6 comma root 2 and negative root 6 comma root 2 and negative square root 6 negative square root 2. So those 4 points right there are where the hyperbola and the ellipse intersect. If you were to graph them each on your graphing calculator or whatnot, you would notice that there are indeed 4 points of intersection, and those are the coordinates.